Welcome to this explainer. Look, if you're an international procurement officer trying to figure out the Chinese B2B medical vehicle market, you are absolutely in the right place. Today, we're tearing into the 2026 price guide and totally demystifying exactly what you're actually paying for when you source an ambulance from China.
Okay, let's dive into this, because this wild price disparity is usually the very first hurdle every single buyer faces. You get one quote for $30,000 and then another for $70,000, and you're thinking, are these even remotely comparable? Well, in a word, no. Procuring a medical vehicle is this massive, high-stakes decision where everyday automotive reliability absolutely has to meet clinical precision. Really understanding this market takes a complete paradigm shift. As our source material perfectly puts it, you are not just buying a van, you are investing in a mobile life support environment. We've got to stop looking at these things as just vehicles, right? We need to start seeing them as what they really are. Clinical spaces on wheels. We are prioritizing clinical safety above absolutely everything else. So, here's our roadmap for today. First, we'll tackle the price tag mystery. Then, we'll hit the 3 pillars of cost: matching mission to machine, the negative pressure standard, and finally, evaluating OEMs and total cost of ownership. All right, starting off with Section 1, the price tag mystery, and unpacking that $30K versus $70K gap.
The truth is, the real value of a medical vehicle is almost entirely hidden beneath the paint. That initial sticker price is just a tiny fraction of the whole story. If you try to cut corners on the underlying engineering, you're risking catastrophic, maybe even fatal failures out in the field. So when we evaluate an ambulance, we have to completely shift our focus away from the sticker price and look hard at the actual internal construction and safety standards.
Moving into Section 2, the 3 pillars of cost. Let's break down the actual anatomy of an ambulance. To really get a grip on this construction, let's move to and see how this builds across the 3 primary pillars of cost. First up, it all starts with the chassis foundation, which dictates the performance. Then, we layer in the medical cabin material science, that's all about sanitation and durability. And finally, the electrical and oxygen infrastructure, which powers the actual life-saving tools. Now, just the chassis alone is going to eat up a massive 40 to 60% of your total cost. A Tier 1 chassis, think your Ford Transits or Mercedes-Benz Sprinters, they command a huge premium. Why? Well, they offer high torque, top-tier safety ratings like ESP 9.0, and a massive worldwide parts network. But on the flip side, Tier 3 chassis, like Foton and Jinbei, are incredibly cost-effective. They're actually fantastic choices if you're dealing with budget constraint, short distance, or maybe low-intensity rural health initiatives. Now, what's really interesting about this slide is how the physical materials literally dictate your clinical safety. The cheaper budget conversions, they use basic PVC or hand-pasted fiberglass. And honestly, they're kind of a nightmare. They crack easily, they are incredibly tough to disinfect properly, and they can even release harmful VOCs. But if you look at the high-end conversions, they use vacuum-formed ABS or integrated FRP, which is fiberglass-reinforced plastic. Those give you this beautiful, seamless, fire-retardant space that's an absolute breeze to clean. And if you're going into extreme off-road or military conditions, you step all the way up to structural aluminum alloy. Our third pillar is the internal infrastructure. And guys, the stakes here are quite literally life or death. Imagine a power surge killing a sensitive ventilator mid-transport, or a sudden failure in oxygen delivery. It's just unthinkable. When you pay premium pricing, you're getting redundant electrical systems. You're getting pure sine wave inverters that feed crystal clean power to those delicate medical electronics. You also get ultra-durable, copper-piped oxygen systems with central manifolds. Basically, you're paying for absolute reliability when it matters the most.
All right, on to Section 3, matching mission to machine, where we look at choosing based on clinical need according to EN 1789 standards.
So, pivoting from the physical materials to how these vehicles are actually used, our first category is Type A, which is the patient transport ambulance. These are built strictly for non-emergency transport. Since their main jobs are passenger comfort and basic stabilization, they're usually smaller, definitely more fuel efficient, and they serve as your baseline option, which naturally comes with a much lower price tag. Next up, we have Type B, the standard emergency ambulance. Make no mistake, this is the absolute workhorse of any EMS fleet. Because of that, it needs a much more advanced internal architecture. It has to be fully equipped for active treatment and monitoring while zipping through traffic. That means you need highly sophisticated, super secure storage for things like drugs, trauma kits, and your basic airway management tools. And finally, we hit Type C, the mobile ICU. These are your high-spec vehicles purpose-built for advanced life support. We're talking heavily reinforced flooring to hold up some seriously heavy life-saving equipment and complex electrical outputs that can run multi-parameter monitors and defibrillators all at the exact same time. Actually, it's really interesting. Tier 2 chassis, like the Iveco Daily or Maxus, are fantastic for Type C builds. They offer this incredible interior height and volume for those massive ICU conversions. It's a genuinely brilliant design advantage to keep in mind if you're configuring a heavy-duty fleet.
Moving right along to Section 4, the negative pressure standard, focusing on specialized infectious disease control.
So, over the last few years, global demand has totally skyrocketed for this highly specialized requirement, infectious disease control. And the crucial point here is this very specific number, -10 to -30 pascals. Look, to safely transport infectious patients without endangering the crew or the public, the medical cabin has to maintain this exact negative pressure gradient. That requires engineering that goes way, way beyond just slapping in a standard AC unit. And honestly, that complexity is exactly what justifies the big price markup here.
So what exactly are you getting for that upgrade? Well, you're paying for a system that locks in and reliably holds that -10 to -30 pascals gradient. Plus, it completely swaps out the cabin air at least 20 times every single hour. And on top of that, it pushes all that air through heavy-duty HEPA filters operating at 99.97% efficiency for 0.3 micrometer particles. When you put it all together, it's literally a mobile cleanroom. Finally, we arrive at Section 5. Evaluating manufacturers and TCO. This is all about long-term reality and the total cost of ownership.
Okay, now that we know the specs, how do you zoom out and actually pick the right Chinese OEM partner? You have to remember, a reliable manufacturer isn't just bolting some cabinets into the back of a van. They're engineering a precise medical space. You need to be asking for their center of gravity calculations, because a poorly balanced ambulance is incredibly dangerous when braking or cornering. You absolutely must verify EMI/EMC compliance so the vehicle's electrical system doesn't accidentally scramble your medical monitors. Make sure you're looking for those ISO 9001 and ISO 1345 medical device certifications. Oh, and definitely check that they use CNC-cut panels with interlocking joints and do proper vibration testing. You do not want those cabinets rattling apart on rough roads.
And this brilliantly illustrates exactly why just looking at the initial sticker price is so deceiving. You have to think about the total cost of ownership. For example, do they include a wear and tear kit with extra fuses, oxygen terminals, and spare latches? How do they handle international warranties? Like, do they give you video technical support and rapid component couriers? And this one is huge. Do they offer climate customization? If you're deploying a unit to the Middle East or Africa, a standard vehicle AC is going to completely fail to cool that cabin in 40-degree heat. You absolutely need an independent, high-capacity rooftop AC. Trust me, planning for this stuff up front saves vast amounts of money, and more importantly, lives over the lifespan of the vehicle. So when you prioritize all of these factors, say combining a high-quality Tier 1 or Tier 2 chassis like a Ford or a Iveco with a tough, vacuum-formed ABS or FRP interior, you get a pretty incredible return on investment. If you keep up with proper engine maintenance, a high-quality build like that can easily give you 8 to 10 years of active, completely reliable service.
So I'll leave you with this final thought as you head into your next procurement cycle. Does the upfront savings of a budget model, the cheaper chassis, basic PVC walls, standard electronics, does that truly outweigh an 8 to 10-year active lifespan and the guaranteed safety of both your medical crew and your patients? It's always a tricky balance of technical scrutiny and commercial pragmatism, but knowing the engineering that's hidden beneath the paint, that puts the power right back in your hands. Thanks so much for joining this explainer.